In this video, we are going to learn about Diophantine equations. The Diophantine linear equations are of the form ax plus by equal to c. It is a polynomial equation whose solutions are restricted to only integers. That is, the values of x and y will be integers. This is named after the ancient Greek mathematician Diophantus, 250 AD. And any equation which is called a Diophantine equation will have one or more unknowns which are to be solved. So here I have only one equation where I have got two unknowns x and y to be solved. In order to solve Diophantine's equations, we need an identity called Bezout's identity. Here, for any integers a and b which are non-zero, we can find the greatest common divisor and let the greatest common divisor of the two numbers a and b, which are non-zero integers, be d. Then there will exist integers x and y such that ax plus by equal to d. That is, I can express GCD of the two numbers as a linear combination of those two numbers itself. Furthermore, there will exist integers x and y such that it satisfies ax plus by equal to n. This will happen only when this d divides n. So if we want to check whether it has a solution, we have to check whether d divides n. If d divides n, then it has a solution. Otherwise, it is not. So in order to find the initial solutions to the Diophantine's equation, these are the several steps we have to follow. Suppose if the equation is given as ax plus by equal to n, that is, I have an equation only in terms of two variables x and y. The first step is we have to use the Euclidean algorithm to compute the GCD. So this is my first one. And then I have to check whether d divides n. If d divides n, then it has a solution. Otherwise, it has no solution. Then I have to reformate the equation what I got in the first step, that is the Euclidean algorithm. Then using the substitutions and going through each and every step of the reformed one, we can find a linear combination axi plus byi equal to d. Now for using this xi and yi, we can find the initial solution, and the initial solution will be x star y star, where x star y star is xi times n by d and yi times n by d. So this ordered pair will be the initial solution for my Diophantine's equation. So whenever we want to find the Diophantine solution, we have to follow these steps. And the general solution for the equation will be, if the initial solution is already obtained as x star y star, then the general solution will be that x star plus any integer m times b by d will be the x value, and the y value will be y star minus m a by d. In order to solve this equation, say 141x plus 34y equal to 30, which is the Diophantine's equation, let us use the several steps we saw in that method. The first one is we have to use the Euclidean's algorithm to get the GCD. Now since the two numbers 141 is our A and 34 is our B, we have to find the GCD between 141 and 34. So since 141 is a higher number, 141 is greater than 34, we can express 141 in terms of 34 as 434 plus 5. And again 34 can be written in terms of 5 as 6 5s plus 4, and 5 will be 1 4 plus 1. So the GCD of these two numbers 141 and 34 will be 1. So since this 1 divides 30, I can say that it has a solution. The solution will exist because the GCD divides that number 30, which is on my right hand side. So now I have to reframe this Euclidean algorithm. So in order to reframe these equations and whatever I got in this algorithm, the first equation, from the first equation I know that 5 is 141 minus 434. From the second I have 4 as 34 minus 6 times 5, and the last one is 1 is 5 minus 1 into 4. So using this, we can get the value for the greatest common divisor at 1, which is 5 minus 1 into 4. So I'm going to take the values whatever I got in the reformed one and I'm going to substitute them back. So for 4, if I substitute from the preceding one, I get 7 5s minus 134. Again, if I want to substitute for 5, I get this result 7 141 minus 29 34. So when we want to get the GCD in terms of these numbers 141 and 34, I say that the GCD of 141 and 34 can be written as a linear combination 7 141 plus negative 29 34s. So even without reforming these equations, if you want, you can directly substitute that and then get the GCD as a linear combination of this A and B. Now, in order to get the initial solution, let us take that linear combination. 141 7 plus 34 negative 29 is 1. In this case, my xi is 7 and yi is negative 29. Now, in order to get the initial solution for this whole equation 141x plus 34y equal to 30, let us multiply this, the first result, throughout by 30. So when I multiply the first result, what I got throughout by 30, I get 141 2/10 plus 34 negative 870 will be 30. So in this case, the value for x and y is 210 and negative 870. So this pair, 210 negative 870, will be the initial solution. So the general solution will be x star plus m b by d, y star minus m a by d. So since x star is 210, a is 140 and b is 34, we get 210 plus m times 34 by 1, since 1 is the value for d, will be the x value. Negative 870 minus m 140 by 1 will be the y value for any integer m, or it is 210 plus 34m is my x star, and negative 870 minus 140m will be my y star, where m is any integer. To find the positive integer solution for this equation, both the x value and the y value, that x star value, y star value, whatever I got in the initial case, must be positive. So if this is positive and I get this inequality, m lying between negative 210 to 30 by 34 to negative 870 by 147, that is m lies between negative 6.18 to negative 5.92. Since m is an integer, this m must be just a whole number. It is, in this case, m will be negative 6. So the integer m satisfying the result to get a positive integer is only m is equal to negative 6. Sometimes you may have numerous values, but in our case we got only one value satisfying this inequality, which is m is equal to negative 6. So to find the positive integer, we need to substitute this value m equal to negative 6 in both x star and y star. So the positive solution will be by plugging in m equal to negative 6 in the value for x star and y star, and we get that as 6, 12. So 6, 12 is the only positive solution for this Diophantine equation, 141x plus 34y equal to 30. Apart from this, we can get many non-positive integers. Maybe we can include some negative integers also. This video helped us to understand what is Diophantine's equation, how to solve Diophantine's equations with two unknowns, x and y. We saw how to get the initial value value solutions as well as the general value for the Diophantine's equation. So this video helped us to understand what is Diophantine's equation. We saw how to get the solution for an equation in terms of just two variables x and y. We saw how to get the initial value conditions as well as the general solution for it. I have posted several videos explaining about the Euclidean algorithm and the GCD. Hope this video was helpful. Thank you for supporting such videos. Thank you for watching and thank you.